Section 10.5 should be pretty painless. It's just teaching you about independent and dependent events. Independent events are events that follow each other, where what happens in the first event doesn't affect the second one. So for example, if you were to flip a coin and then roll a six-sided die, what's the probability that you get heads and a 6? In order to figure this out, you just find the probability of getting heads times the probability of getting a 6. These events don't affect each other at all, so we just multiply those two together and we get our answer. So the probability of getting heads is going to be 1/2. The probability of getting a 6 is 1 in 6, so the answer is just 1 in 12. The next example is for dependent events. It says, in a shipment of 20 computers, 3 are defective. 3 are randomly selected and tested. What's the probability that all 3 are defective if the first and second ones are not replaced after being tested? So for dependent events, what happens next is affected by what happens before. So we need the probability that the first one is defective. We have a 3 in 20 chance of it occurring, times the second one being defective. We have 2 of them left, and now there are only 19 to choose from. The third one, there's 1 of them left, now there's only 18 to choose from. So dependent events are just where the second one and the third one are affected by what happens in the first one. So multiplying all those together, we get 6 over 6840. And if we're going to simplify that, we can divide the top and bottom by 6. So we get 1 over, we'll divide 6840 by 6 and get 1140. The last thing is, I just want to give you a quick example of how this is denoted. So the probability, what we're looking for is, we want the probability of A happening plus B happening plus C happening for the example above. We want a defective computer plus another defective computer plus another defective computer. So the way we write that is we find the probability of the first thing happening times the probability of the second thing happening given that this first thing already happened. Then we want to also multiply it times the probability, I'm running out of space, so I'll put it on the bottom. So times the probability of C happening given that A and B have already occurred. So just like in the last section, if we're given all the pieces of the information except for one piece, we can solve for the final piece. Like if it gave us the probability of this and this, and the total probability, we could solve for this last thing. And we can just plug in numbers where we need them.